Welcome back to Smart Prep, your daily dose of GMAT Quant practice. Hit that subscribe button and turn on the notification. Let's dive into today's question. How many three-letter codes can be formed by choosing without replacement three letters from the word pepper? That means we have to find out the codes which are of three-letter codes which can be generated using the alphabets or using the letters of the word pepper. Now in pepper, we understand that how many P's are there? We have three P's in the alphabet or in the word that is pepper. There are three P's which are available. E's, how many E's are available? There are two E's which are available and one R which is available. So we have these all alphabets with us. Now, how can we fill these three slots with the alphabets which we have? It could be case number one that all the alphabets here are different. All letters are different. Let's say P, E, and R. Case number two, there might be two E's, right? There might be a case where two E come and the third is R, or two E's come and third might be a P. Similarly, we can take two P's. We can take two P's. If we take two P's, the third could be E, or case number next, that is third, two P's and third could be R, right? Now we have taken two P's. Still, we can take all three P's as the letters or the slots for these slots. All threes are P. So these are all the possible cases which we can have all different alphabets, all different letters. There is repetition. E is coming two times, P is coming two times, and in the last case, P is coming three times. Why? Because we have three P's with us. So that's how these are the all possibilities wherein we can fill these three particular slots of the alphabets. Now for case number one, how can we fill these three alphabets can rearrange in three factorial ways? So can we say that these three can rearrange in first case number one? Let's number it. Case number one. How can these three be rearranged? They can rearrange in three factorial ways. Case number two. These three objects where E is coming two times, right? Three objects can rearrange in three factorial ways. Divided by 2. Why? Because there is a repetition. Whenever repetition comes, you have to divide by. So E is coming two times, so divide by that factorial. Next case, case number 3. So first two cases done. Case number 3, three objects, they can rearrange in three factorial ways. And there is a repetition also. Again, E is coming two times. So what is coming two times? You have to divide by that. Next case, three objects, they can rearrange in three factorial ways, right? And P is coming two times, so we have to divide by that. Next case, similarly, three objects, they can rearrange in three factorial ways, and P is coming two times, so we have to divide by that. This case also done, and last case, three objects, they can rearrange in three factorial ways, divided by 3. Why? Because 3 factorial. Why? Because all P's are there, right? So we have done in a manner to understand that all these are the ways in which these possible cases can rearrange, right? Now, if these are the cases, we have to just add them. 3 factorial plus this, plus this, plus this, right? We have to all add all of them. Now, can we say that to simplify 3 factorial plus 3 factorial upon 2 factorial, 3 factorial upon 2 factorial, this is coming 4 times. These, so we can say that 3 factorial upon 2 factorial times 4. Why? Because they are getting added 4 times. This plus this plus this plus this. They are getting added 4 times, right? That's these 4 cases added together. 3 factorial upon 2 factorial into 4. And last case, 3 factorial upon 3 factorial, that is 1, adding 1 here. Now let's simplify it further. So 3 factorial, that is 6, upon plus 3 factorial, that is 6, upon 2 times 4 plus 1. Got this? This is going to be 2. So that means 6 plus 6 times 2, that is 12, plus 1, that means 18 plus 1, that is 19. So we have 19 such possibilities, or 19 such codes can be formed using the alphabets of the word pepper. So our answer is option C, that is 19 is the correct answer. If you found this video helpful, give it a thumbs up.